Hope I'm audible. Let's start the session now. So, welcome to the NPTEL live session for the course Integrated Waste Management for a Smart City, Week 8. I'm Abhishek Raj, PMRF scholar in the Department of Civil Engineering, IIT Madras. So, going to the outline of today's session. So, firstly, we will go through a overview of Week 8. Then we will have discussion on the practice assignment questions, and then we can take on some doubts. Starting with the overview on week 8. So firstly, lecture 1 was about stoichiometric combustion. So using chemical balance equations and balancing the equation, we try to obtain how much oxygen is required for the combustion of the waste material. Then based on how much air we require or how much oxygen we need, we design the combustor. Then there was lecture 2. So this was also about thermal treatment. And here we discussed the part on incinerators. What are the different types of incinerators? And how is air pollution control achieved in these different types of incinerators? And how much efficiency can they provide us? Then lecture 3 was about the case study in Europe, where one research paper was discussed. So they basically collected data from waste to energy plants across Europe, and then they tried to analyze the emissions from these waste to energy plants. So the emissions were discussed, different types of emissions, and also the issues arising. Followed by this was lecture 4. It was about the advanced thermal technologies. So this includes technologies such as pyrolysis, gasification, plasma. So what are the air requirements and what are the heat values of the waste that should be ideal for this kind of trade. Then last lecture was about landfill issues. We just check it sometimes waiting. So last lecture was about it is basically a continuation for week 9. So landfill, what are the different issues? So if the landfill issues contain such issues such as odor, litter, uh, reduction in the property value, and other such things are there. Moreover, it is not a preferred option. So first discussed in this part, and then we had the different types of liner systems that are used in landfill. So what is the purpose of the liner system? So it prevents leachate, infiltration. So this was the basic overview for week 8. Now we will discuss the questions. So we'll start with question 1. So this is a poll. So select the correct order of the steps in the combustion process. So you will be given the order and you have to select which one is the right sequence. So first is drying phase, volatilization, burn down of char and burn down of solids. Again, volatilization of vapors and gases, burn down of char, burn down of solids, and then drying phase. Burn down of char followed by volatilization of vapors and gases, and burn down of solids in drying phase, and finally drying phase, vapors and gases, burn down of solids, and burn down of char. So I will drop a poll. You can answer it also in the chat. This question 1. So someone has answered D. We have two people here, so I'll wait for 1 more minute. Then we will move on to discuss the answer for this. So I think we have one more response. We will discuss the solution for this now. So when we talk about combustion, so there will be different stages in this. The first stage will be uh, we try to remove the moisture. So this is called as the drying phase. So this is a pre-processing step which is done before combustion. We don't want wet waste in the combustor, so the more dry it is, the better will be the combustion. Also, we should not make it very dry, so there is an optimum moisture content that we should try to try out. So firstly, we will have drying phase. So here we can see we have drying phase here and we have drying phase here. So A and D. So we can remove B and C directly. So we are left with two options, we'll C and. So followed by this, what we try to do is we try to volatilize the vapors and gases. So this, the first stage, this is achieved at around 150 degrees Celsius. So we would only want to remove the moisture. So we take it higher than the boiling point of water at which it will convert to vapor. Then for stage two, we go higher, we go around 700 degrees Celsius. So then, and then stage three. So now the moisture is removed, the gases and vapors have been volatilized, and now basically we will have the solid content. So we'll try to burn down the solids or combust the solids. Then followed by this, we will have the last stage. So after burning of solids, so basically we'll have the solids. So we'll have the wet solids. So we did the drying phase and the volatilization. So we'll be left with solids. And when we combust this, we will be left with char. So that will be burned down of char. So after char, since we burn down the char, we will be left with nothing but ash. So these are the four stages. So firstly, we have drying phase. Then we have the volatilization of vapors and gases. So it is correct. So okay. So in D also it is given the same. So here it is correct. Then A it is given burn down of char. So no. Firstly we'll burn down the solids and then we burn down the char. So we can remove A. So we are left with burn down of solids, burn down of char. So option D is the correct answer. We'll discuss this using the slide also. So drying phase, volatilization, burn down of solids, and then burn down of char. So option D was correct. Students can refer to the first lecture of this week for this question. So here we can see the process is accomplished in four phases. So there is a drying phase, so where we drive out the moisture at 150 degrees centigrade. Then we volatilize the vapors and gases. So this will occur at a higher temperature around 150 to 700. Then we will take it even higher for burning down the solids. So up to 1100 we will take it. So there we burn down the solids. So this is phase one, phase two, phase three, and finally we burn down the char, that is phase two. So in these four stages, the mechanism of combustion is performed. Moving on to the second question. So it is a similar question. So here we have to match the phases of combustion. It should be phases, not passes. So phases of combustion with respective description. So drying phase. So drying phase, it has the nature of fixed carbon volatile material are oxidized. Then we have volatilization of vapors and gases, moisture is driven, and burn down of solids. So then the options are given. Then we have also burn down of char. Then we have the four options. So here we can see, as we discussed in the previous question also, I think someone has just checked. Someone is joined. So I think we have new people, so I will just repeat once quickly. So first phase, we dry the waste. So this is done up to temperature of 150 degrees Celsius. So the purpose is to remove moisture. So here we can see we have drying phase here, that is one. So which will it go with? It will go with moisture is driven off at 150 degrees Celsius. So let's just write it here. So one went with two. Then we have phase two. So here we volatilize the vapors and gases. So here we raise the temperature. Here we go up to 700 degrees Celsius. So this is the volatilization of vapors and gases. So here we combustible volatile organics will diffuse out when their flash point occurs. So this will be around 150 to 700 degrees Celsius. So two went with four. Then we are left with burn down of solids. So that will be phase three. So we burn down the solids, and finally we'll have the phase four. So after we burn the solids, what will be left? Char. So we burn the char. So burn down of solids, this will go with fixed carbon volatile material. So this will be oxidized. So firstly we went to 150 degrees Celsius. Then second stage will go to 700. Third stage we go up to 1100, and then we finally will burn down the char. So three will go with one. So three will go with one, and finally four will go with yeah. So four will go with remaining char is one. So four will go with three. Just a second. Four will go with three. So one with two. So that is one is one with two, two with four, three with one, and four with three. So option B is the correct answer. Moving on to the solution. So we'll see the same solution similar to question one. So option B was the correct answer. So students can refer to the first lecture of this week. So the combustion process is accomplished in four phases. The drying phase, we drive out the moisture at 150 degrees Celsius. Then we volatilize the vapors and gases, so around 150 to 700. Burn down of solids at even higher temperatures, and then finally, in phase four, we will burn down the char. So this is the mechanism of combustion. Moving on to question number 3. So baghouse fabric filter is used to remove which of the following pollutant generated during the combustion process? So nitrous oxides, sulfur oxide, particulate matter, and acid gas. So baghouse filter is basically like will be a bag of microfiber cloth. So microfiber, and there are other kinds of cloths which are used nowadays. So a simple example of where microfiber cloth is used is so I don't know how many of you use the specs. So the spec box will usually have a cloth along with it. So that cloth is microfiber cloth. So the purpose of that cloth is the fabric is made in such a way that it can attract any kind of particles from the surface of the glass. So that helps from preventing any kind of scratches. So that's why they say we should use that cloth instead of using any other cloth. So that is the purpose. So this microfiber cloth is especially meant for particles. So it is not small enough. The pore sizes are not small enough to stop any kind of gases. So A and B cannot be the answer. So we generally use it for particulate matter. So answer C is correct. Moving on. So we'll discuss the slide also. So option C, particulate matter, is the correct answer. Students can refer to the first lecture of this week. So here it can be seen for nitrogen control. For nitrous oxide control, we use injected ammonia, and for SO2 and acid gas, we use the dry scrubber, and baghouse we use for particulate matter. So that it can attract the small particles, that is such as PM2.5, PM10, which are the standard pollutants usually released from the combustion of the uh, organic matter. So these are the two of the primary pollutants. There are other particulates also for these kind of particulate matter, baghouse filter. Moving on to question number 4. So this is a poll. Which of the following waste to energy system uses the highest temperature? The given options are fluidized bed, pyrolysis, plasma arc, and gasification. So I'll drop a poll. You can also answer it in the chat. Give maybe 2 minutes for this, then we will discuss the answer. Launch the poll. Everyone has responded. We'll discuss the answer for this. So what all are the responses? So I think two people have said C and one person has said B. So when we discuss waste to energy systems, so there will be basically two types. The first will be the conventional systems, so that have been used traditionally, and certain advanced or modern systems have also come in use now. So conventional systems will contain like fluidized bed is an example of conventional systems. In advanced, we have systems like plasma. So here what we basically do is, so plasma is a state of matter. So what are the different states? So I'll just say, so solid is there, liquid is there, gas is there, plasma is there. This is the fourth state of matter, and some also say there is another fifth state. So that is the Bose-Einstein condensate. So plasma, when we see, basically it is ionized. So we'll heat up. We'll have a gas in a container. So based on ideal temperature and pressure for that suitable gas, so we'll heat it up. So what happens is the particles get ionized. So they release electrons. So it will be a mixture of the atoms and the electrons in an ionized state. So that is plasma. So here what we do is, in plasma arc, we basically heat up the waste material at a very high temperature. So that kind of releases the electrons and helps to volatilize the gases and vapors that are released. So highest temperature need, because we need to eject the electrons from the solid material. So option C is the correct answer. So I think someone said pyrolysis. So yeah, that is not correct. So option C, plasma arc, students can refer to the fourth lecture of this week. So yeah, it is a state of matter created by heating a gas in which a certain portion of the particles are ionized. So it can be created with almost any kind of gas. So nitrogen, oxygen, air. We need to heat it to extreme temperature of 2000 to 6000 degrees Celsius. So this ionized gas will be able to conduct electricity because it has electrons. So these are free-flowing electrons, so they can transfer electricity. Moving on to the next question, question 5. So which of the following statement is true for air pollution control measures taken during thermal treatment of waste? So cyclone separators are used for efficient removal of particulates using an electrostatic charge. Baghouses are used for efficient removal of particulates using an electrostatic charge. Baghouses are used to remove particulate matter using fabric filters. Last option we have is none of these. So let's take the options one by one. So cyclone separators are used for efficient removal using an electrostatic charge. So no, this is not correct. So what does a cyclone separator do? Basically, it will have mechanical motion to kind of sediment the different particles or the particulates which are present in the pollutant or the fuel. So that is how a cyclone separator works. It does not work using electrostatic charge. So what uses electrostatic charge? So that is ESP, or also called as electrostatic precipitator. So nowadays even the vehicles, so in the BS6 grade of vehicles, so cars and bikes also must use this electrostatic precipitator to filter out the particulate matter before releasing the fume into the atmosphere. So this is a standard that is being used. So you can remember that ESP is also used in cars and bikes nowadays. So second option is baghouses are used for efficient removal using an electrostatic charge. So this is also not correct, as we discussed in one of the previous questions. So baghouse is simply for filtering the particulate matter using the cloth. So baghouses are used to remove particulate matter using fabric filters. So yeah, this is correct. So it will simply be a bag. It will be like not just one bag. It will be like multiple sets of bags will be there. So the gas will be simply passed through this. So whatever the particles will be, so basically they will get stuck to the cloth or kind of get absorbed in the cloth. So that is how a baghouse filter or a fabric filter works. So option C is correct. So baghouses are used to remove particulate matter using the fabric filters. Students can refer to the second lecture of this day. So electrostatic precipitator, it uses a induced electrostatic charge to remove the particles from a flowing gas. Here, an engineered fabric filter is used which will have basically long bags and tubes to remove the particulate matter. So baghouse is to remove particulate matter using fabric filters. Moving on to question number 6. So highest percentage of particulate removal can be obtained using which of the following air pollution control system? Given options are Venturi scrubber, spray dry absorber, packed bedwet scrubber, and dry electrostatic precipitator. So when we talk about air pollution control systems, so one of the highly rated and highly efficient systems is a dry electrostatic precipitator, because it is able to remove attain a high efficiency, like higher than 90% it is able to achieve in some cases. So compared to this, Venturi scrubbers or absorber, scrubbers can be dry and wet both. So that is mentioned here in option B and option C. So in some cases, what is done is, so the gas is sprayed with water before passing it into the filter. So what that does is the gas molecules kind of they absorb water or kind of react with water, so they become heavy. So it becomes easier to remove them compared to a dry gas. So that is the mechanism of using the scrubbers. So, but their efficiency will not be as high. So A, B, and C you can remove. So here we want the highest percentage of particulate removal. So for that we can go with dry electrostatic precipitator. That is option D. So dry electrostatic precipitator is the correct answer. Option D. Second lecture students can refer. So here we can see the classification of the air pollution control systems. So we have the dry absorber, we have Venturi scrubber, we have packed bed, and we have the dry ESP. So here we can see the particulate removal. So for dry absorber, it will be like low levels. Venturi will get good levels. Packed bed, again low levels, and here we can see for dry ESP, we can get a high efficiency, excellent. So it will usually be higher than 80%, 85%, some cases even 90% it can be easily. Another issue with the scrubbers is that regular cleaning needs to be done, and the cleaning part also needs to be done in dry ESP, but it is much more easy to do here. It is also one thing. So moving on to the next question, question 7. So this is a poll. So match the following properties of ash produced with their description during thermal treatment. So non-putrescible, sterile, and inert. We need to match them with does not react in any way, free of living organisms, and does not decay. So the options have been given. I'll just drop a poll. You can answer it in the chat as well. Question 7. I'll give maybe 2 minutes for this. You can answer it. So we have two responses, B and C. We wait for 1 more minute. So we have 4 people here. Wait for 1 more minute. We'll discuss the answer. Any more responses? I think there is one response in the poll for D. I think two responses and B and C in the chat. Close the poll now. Let's start. Someone send D in the chat. Okay. So firstly, let's not just think about waste. Let's just try to approach this question from the meaning point of view. So what does the word putrescible mean? So basically it means something which can decay. So non-putrescible will mean something which cannot decay. So one will go with 3. Then we have, let's say we take inert. So surely you would have heard about the inert gases. So contain gases like argon, neon, xenon. There are other gases. I don't think xenon is now. So argon, neon, these kind of gases are inert gases. So why are they called inert? Because they do not react. So they are, so three will go with one. So now we are left with just one. So on two will automatically go with two, but still let's discuss that. So sterile is something which does not have the capability to reproduce. So or so what is that? So basically reproduction is about living organisms. So if something is sterile, it will be free of any living organisms. So two will go with three. So we have three, two, and one. So I think we have three here, one here. No, but we need two here. So three is also here, two and one. So option D is correct. So I think it's correct. We have two responses for D and okay, so I think three people responded D. So that is good. So yeah, we'll discuss this using the slide also. So one with three, two with two, and three with one. So option D was correct. Students can refer to the second lecture of this week. So when we generate ash in an incinerator, so it will be a continuous generation, and three types can be there. So non-putrescible, it will not decay. Sterile, it will be free of any living organisms, and inert, does not react in any way. So these are basically the possible properties of ash using which it can be classified. Moving on to question 8. So which of the following factors control the head on the liner system in landfills? So liner slope, impingement rate, hydraulic conductivity of the leachate collection system, and number of horizontal and vertical wells. So basically, we have a landfill. We will try to put a liner below it so that the infiltration that is happening does not reach the groundwater or does not leach off from the landfill area. So what is the slope of the liner? That will surely matter, because the slope is like this. The head is basically the height from which the water head is coming. So first origin point for the head will be the top surface of the landfill. So that is how it is assumed. So the full height of the landfill will be like the head. But if the liner is slope, so you can see that the head will increase from the top surface. So liner slope will matter. So A is correct. Then impingement rate is basically the rate at which the infiltration will be happening through the landfill material. So B is also important. Hydraulic conductivity is kind of similar to impingement rate. So basically that is the permeability, the ability of the leachate material to pass the water, or the not water, it is the leachate. So the ability of the collection system to pass the leachate. So C will also matter. A, B, and C. The number of horizontal and vertical wells. So this does not have any concern with the head on the liner system. So D is not correct. So A, B, and C are correct. So yeah, I think someone answered it in the chat also. Nice. We'll discuss this using the slide also. So A, B, and C. So liner slope, impingement rate, and hydraulic conductivity, they influence the liner head. So the last lecture of this week you can refer to. So here we have the liner slope, pipe spacing, the collection systems, hydraulic conductivity, and impingement rate. So these all factors control the head on the liner. Moving on to question number 9. So out of the following principal elements of municipal solid waste, oxygen is required for combustion under ideal combustion conditions of which of the following elements? So carbon, nitrogen, hydrogen, and sulfur. So I'll just give a few seconds. So can someone answer it in the chat? So what will be the answer for this question 9? Okay, so someone has said A, B, and C. Any other responses? We'll discuss this. So here the key word is we are talking about ideal combustion conditions. So in that what happens? Carbon will take 1 mole of oxygen, form SO2. Sulfur will take 1 mole of oxygen, form SO2, form CO2, SO2, and then we have hydrogen. So hydrogen will be H2 plus R42 will form one water molecule. But what is the case with nitrogen is it is somewhat of an inert nature. So under ideal combustion conditions, so before we can break N2 into 2 nitrogen and then it can react with oxygen, what happens is once it divides into 2 nitrogen atoms, just a second. So before it can form a nitrous oxide or any other type of oxide of nitrogen, it again clumps back together and again goes back to N2. So basically it will be like N2 2N. So it will be equilibrium reaction. So this will be happening back and forth. So nitrogen molecule will get destroyed and form nitrogen atoms and again they will clump to form N2. So this is under ideal conditions. If there is deficiency, in less oxygen or when the oxygen is not sufficiently provided, so they will form nitrous oxides. So we'll need it for carbon, we'll need it for hydrogen, we'll need it for sulfur, but we don't need it for nitrogen. So A, C, and D are correct. So A is carbon, C is hydrogen, and D is sulfur. So we can refer to the first lecture of this week. The principal elements of solid waste are carbon, hydrogen, oxygen, nitrogen, sulfur. So under ideal conditions, what gases will be formed? So carbon dioxide will be formed, which will be from carbon. Water will be formed, this will be from hydrogen. Nitrogen will be formed from nitrogen, and from sulfur we will get sulfur dioxide. So we'll need oxygen for the combustion of carbon, hydrogen, and sulfur. So CHS, for that we need O2. Moving on to question number 10. So this is a poll. So which of the following statements are true for different incinerator types? Fixed hearth incinerators are normally used for smaller quantities of waste. Rotary kiln incinerators are normally used for smaller quantities of waste. The secondary chamber of rotary kiln incinerator is used for gas-phase combustion, and the secondary chamber of fixed hearth incinerator is used for gas-phase combustion. We'll just drop a poll. You can answer it in the chat also. This is question 10. Drop the poll and give maybe 2 to 3 minutes for this. You can answer it. We have one response. A and C. Okay. I'll give a hint. So 2 of the options are correct here. Do we have any more responses? Three people have responded A and C. Just check the polls once. So someone has said A in the polls. So polls anyway, you can't answer polls. Okay. When the poll, we'll discuss the answer. So here we are concerned about the fixed heart incinerator. Rotary kiln incinerator. So fixed heart, basically it's like will have a small structure and is generally used for smaller quantities of waste. Cannot deal with very large quantities of waste, so this will be used for incineration of biomedical and pharmaceutical waste. So they will be biomedical facilities and pharma research facilities. So they are supposed to install a incinerator so that they can deal with the waste internally. So they will use this because they won't have much of a waste production because it will be very controlled. So smaller quantities of waste only they will deal with. So A is correct. So rotary kiln, no, it is not used for small quantity. We can use it for larger quantities. So B is incorrect. Then we are left with C and D. So secondary chamber of rotary kiln incinerator is used for gas-phase combustion. So yeah, this is correct. So first, there will be two chambers in this. So let's call them C1, C2. So C1 will basically pass the waste and it will get combusted in the first chamber. And for any kind of volatile or gaseous matter, gas phase combustion. So that for that we use the second chamber. So C1, C2. So secondary chamber will be used for gas phase combustion. So C is correct. Then we are left with D. So secondary chamber of fixed earth incinerator is used for gas phase combustion. So this is not correct. So A and C are correct. So I think three people said this. So that is good. Let's discuss this during the slide also. So option A, fixed earth incinerator, normally used for small quantities, and option C, secondary chamber is used for gas phase. Students can refer to the first lecture. So here we can see the slides, the snips from the slides. So fixed earth incinerators will have a stationary kiln. So that is in the name itself, fixed. So first type of waste designed or used, so normally used for smaller quantities of waste in medical facilities. So waste will be charged into the incinerator and combusted as it passes. So from the last earth, we'll get out the residue, that is the ash. And when we talk about the second type, that is rotary kiln incinerator, so there will be two chambers. So firstly, we'll charge the waste into primary combustion chamber, which will be refractory line. So refractory is nothing but it is a lining on the interior of the chamber. So this prevents the chamber from getting damaged from the high heat that is getting generated. So refractory is used. So it forms around very small part, like 2 to 3% of the cost of the incinerator. But it is a critical material because a failure of the refractory material can lead to a failure of the incinerator. So small cost, but high application material it is. So that is used in the inside the lining. So the kiln will be turned slowly. So there will be the kiln. So it will be turned at around 1 RPM. So one rotation per minute will give. So this basically tries to mix the air within the incinerator uniformly with the waste. Because if the waste is stationary and it is burning, so the oxygen may not get mixed with the waste properly, and some part or some portion of the waste may get left like it will not properly burn. So for that we try to give it slow rotations. So material is burnt while it tumbles down the kiln. So along with the rotational motion, it will also have a kinematic motion straight down, and then it will go through the second chamber where we do the gas phase combustion. Moving on to question number 11. So which of the following processes come under the category of conventional waste to energy technology? So the given options are plasma, fluidized bed, and pyrolysis and rotary kilns. So here we are concerned about waste to energy. So first group will be the conventional technologies that are used. The second will be the advanced technologies that are used. So in conventional, we will have fluidized bed, rotary kilns, simple mass burn. When we talk about advanced tech, so as we discussed in one of the previous questions also, so plasma arc, pyrolysis, gasification, these will come under advanced technology. So here we are concerned with the conventional tech. So conventional will have fluidized bed, that is option B and option D. So plasma is not conventional, it is advanced. Pyrolysis is also advanced. Fluidized bed and rotary kiln are conventional techniques. So B and D are correct. So option B and option D, fluidized bed, rotary kiln. Students can refer to the second lecture of this week. So waste energy plants are intended for the recovery of heat energy and to generate electricity. So conventional waste energy will have mass burn, fluidized bed, and rotary kiln. So here we will use try to use refuse derived fuel. And advanced waste energy will have gasification, pyrolysis, and plasma. Moving on to question number 12. So which of the following statements are true for solid residues generated during thermal treatment of waste? So bottom ash is suitable for road base and landfill cover. Fly ash is suitable for road base and landfill cover, and fly ash needs to be stabilized before disposal. And the last one, it is bottom ash usually needs to be stabilized before disposal. So can I just have one or two responses on this? One has said A and C. Anyone else? So we have two responses, A and C. So here we are talking about the solid residues that are generated during the thermal treatment of waste. So this will have two types. So bottom ash will be there and fly ash will be there. So fly ash will be generally like will have a light or not light won't be the correct word. So will have a low density. On the other hand, bottom ash will have a higher density compared to fly ash. That's why it settles down to the bottom. So and fly ash kind of remains on the top. So it is called as fly ash. So fly ash is suitable for road base and landfill cover. So as I said, it is a low density material. So generally we don't prefer a low density material for road base and landfill covers because we need it to be heavy so that it can properly perform the purpose. So road base, what do we use is, so aggregate is used. So how can we replace it? So aggregate, what will be the specific gravity? So it will be around 2.6, 2.7. So fly ash certainly won't have this high specific gravity. So you can't use it for road base and landfill cover generally. So B is not correct. Then fly ash usually needs to be stabilized before disposal. So yeah, this is correct. This is because it has a low density, so we cannot directly dispose it. First, we'll apply some stabilization. It is mixed with other kinds of material such as sometimes cement, soil, and other purpose like chemicals are used for stabilizing it, basically trying to increase its density so that it does not spread out. So C is correct. Then we are left with bottom ash. So bottom ash, since we saw it has a higher density, so we can easily use it for road base and landfill cover and other purposes to replace the use of aggregate. So A is correct. Generally, it does not need any kind of stabilization before disposal. So you can remove the last option, that is option D. So option A and option C are. So we'll discuss this using the slide also. So bottom ash is suitable for road waste and landfill cover. So option A is correct. And fly ash needs to be stabilized before disposal since it has a lower density. So C is correct. Students can refer to the second lecture of this week. So here we can see the solid residues. So when we are doing conventional combustion, so we will have bottom ash and fly ash. So bottom ash suitable for road waste, landfill cover or disposal, and fly ash will need to be stabilized before the. In advanced combustion, we will have slag. So this was the last question for today's session. So if you have any doubts, you can ask. Else, please feel free to log on.
Sir, explain me about what is a landfill liner. Quickly discuss, please.
Yeah, so just give me a second. Let's check this question. So liner is nothing but student. So we have the landfill. So what happens is this contains different kinds of solid waste, which may be hazardous. Hazardous in the sense not very hazardous, but still hazardous like compared to the environmental standards that we want to maintain. So different types of solid waste it will have, which will be decaying also. So when it rains or there is some kind of water entry into the landfill, that is the dump. It's not just call it landfill, it's just call it a dump of waste. So due to this, it carries along with it the waste material. So it gets absorbed into this. So this process is called as leaching, and the material or the liquid that will be formed is called the leachate. So leachate is basically it is lethal. So like we should not get leachate mixed with groundwater, which will be basically below the ground surface. So if this leachate reaches the groundwater, it will contaminate it. So we should not let that happen. So how will we stop it? So we'll collect the leachate. So for collecting it, we will place a liner. So basically liner, what it does is from all the water, all the leachate that is coming, we'll collect it and we can finally collect it and kind of store it in a facility. Different well, horizontal and vertical wells will be there. So that is the purpose of a liner, to collect the leachate. It tries to basically prevent the infiltration of the leachate into town.
Okay. Thank you.
Does anyone else have any doubt? I'll wait for maybe one more minute, then we'll close the session. Yeah, thank you. if anyone does not have any doubts, close the session now. Thank you for attending the session. See you next.